And today should be, there's no like calculating you have to do today, okay? So what we're looking at today is just the different types of data displays. Which data display to use and when to use it. Okay, are there lots of different types of graphs you can look at? I think so, okay. So your notes today are all about the different types of graphs you might see. Okay, so the first one, I'm gonna start my video here. Oh, Savannah's trying to get in. Let me let her in. The first type of graph we're gonna look at is a pictograph. When do you typically see pictographs? I think a lot of times you see them in elementary school, right? Yeah. Pictographs are really easy for more elementary type students to read. They're a little bit more interesting for elementary students. They're easier to read. But it just shows data using pictures. Okay, so this is an example of a pictograph. Now, we have to be careful if we're making pictographs because our pictures all need to be about the same size. We can't have some pictures way bigger than others, that type of thing. But it just shows data using pictures. Pretty easy, okay? So this is showing how many items were sold. 10, 20, 30, 40, 50, about 55 chips, something like that, because there's a half a bag at the end. How much chocolate was sold and how much candy was sold. Okay? Okay, then the next type of graph is a bar graph. Okay, a bar graph shows data in specific categories. So underline, circle that word. When we're looking at categories of data, we're going to use a bar graph. What are some different types of categories we might have? This one talks about favorite color. What else might we see? What kind of questions might you ask that we might end up with a bar graph? So we can ask about favorite color.
Favorite games.
Games, food, right? Colors, games, food. Okay. The different states you have visited, that type of thing, where each state would then be a bar, and you're showing that. Okay? Okay, so we have bar graphs as categories. The next one is circle graph. Okay, we use a circle graph because it shows data as parts of a whole. Anytime we're dealing with percents, okay, if we're looking at things like a family's budget, okay, where they spend part of their money on food, part of their money on clothes, part of their money on rent, put some of it in savings, the rest went to miscellaneous items, okay? So if you have a whole amount of something and you're talking about how much was on each part, okay? If I had data about the 7th grade class and I wanted to show the percent of boys versus girls, okay? Or if I wanted to take the MCA data and I wanted to show the percent that did not meet, partially met, or exceeds. Okay, I would show that in a circle graph. Okay, questions there? All right, the next one is a line graph. A line graph shows how data changed over time. The most important thing here is you're showing change over time. Okay, so whether that be days of the week, months, years, you're looking at change over time. Okay, so it might be, in this particular graph, it's average daily temperatures. It's showing the temperature each day of the week. Okay, if we did that this week, we would see that the temperature was started pretty low, and it's quickly rising, right? This morning when you walked out of your house, wasn't it awesome?
It's supposed to be like 6.
Like the sun is shining. That was the number one awesome factor, was the sun was shining. But it felt better out. Okay, last night sitting at a 7th grade baseball game was awfully chilly by the end. I didn't even care if they won or lost. I just wanted to go home because I was cold. Okay? I'm just kidding. I did care, but I was really cold. And TJ took my coat, so I didn't have a coat to stay warm anymore. So this is showing temperature. We could show things like gas prices, okay, or the stock market. A lot of time you'll see a line graph because it's showing how those prices would change over time. Go ahead, Brooke.
Like data or like your grades or.
Yeah, you could show your grades like per quarter.
Yeah.
Absolutely. So you could make a graph of your math grade each quarter, right? First quarter, second quarter, third quarter. And some of you might notice that you have a very steady line because your grade is stayed the same. Some of you, your grades might have went up or down. Okay, and yeah, that would be showing your grades over the quarters would work. Okay, now showing, if I wanted to show the number of people that had A's, B's, C's, or D's, or F's, then would I use a line graph? No, now what kind of graph would I use? A bar graph or a circle graph. Okay, a bar graph because you could show the number of people in each category. A circle graph, you could show the percent of people in each category. Okay. All right, the next one is a histogram. Okay. A histogram, it kind of looks like a bar graph. Okay. So it is a bar graph, but it shows frequencies of data values in intervals of the same size. The key in a histogram is we have intervals. So circle that word, intervals. Okay, you will notice that when we're looking at histograms, the bars all touch each other. Like a bar graph, they're all spread out, right? There's space in between them. In a histogram, the bars touch. Okay, and your labels on the bottom here are always going to be like this. It goes 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Okay, and actually, this graph I think is a little wrong. This first bar can't say 0 to 10, and the next bar say 10 to 20. Because we don't know where 10 is. Is it in the first bar or the second bar? Can't be in both, right? So this should probably say 0 to 9. And then 10 to 19, and 20 to 29, and 30 to 39, and 40 to 49. Does that make sense? Because you wouldn't want to include data in 2 different bars. But we are showing those intervals, and that's kind of the key thing there. Okay? Flip the page. Okay, a stem and leaf plot, we talked about this Monday. We already know how to make stem and leaf plots. Stem and leaf plots, orders are numbers. So it puts them in order, and it shows how they're distributed. Okay, it kind of shows how they're spread out. It's almost like a bar graph on its side. Right? I can see how many people are in the lower amount and how many people are in the upper amount. Okay, this stem and leaf plot is obviously about age because the key says 6'3" means 63 years old. So we have people all the way from 1-year-old up to 66 years old. And do we have more younger people or more older people according to that stem and leaf plot?
More younger.
More younger people, right? There's more people in their like single digits, teens, 20s than there are up in the 40s, 50s, 60s. Okay? All right, the next type of graph is a box and whisker plot. Have you ever seen one of these graphs? You don't see these very often. A box and whisker plot, it's called a box and whisker plot because it has boxes, and these lines on the end are called whiskers. So box and whisker. Okay, literally that's why it's called that. It shows the variability of a data set in quartiles. Okay, so what it really means is quartile splits it into fourths. It takes your data and it splits it into fourths. Okay, now most often you guys would maybe see this when the state of Minnesota sends out your testing results for like an MCA test. Okay, and it's showing you what the lowest score was. If this was MCA testing, maybe the lowest score was a 20. The highest score was a 100. And half of the people, the median right here, means half of the people got about 68 or better, and half of the people got 68 or less. And then they would put a dot somewhere on the graph for you. So maybe that is you. That means you were in the top half of the class. Okay, and you can kind of see how spread out it is. We don't use box and whisker plots very often. Okay? All right, the next one is a line plot. We've used line plots. We made line plots. Okay, shows the number of times each value occurs in a data set. So if we're keeping track of how many hours spent watching TV, okay, and we surveyed our class about how many hours they spent. Some people didn't watch TV at all. 1, 2, 3, 4. Okay, I don't think this should be watching TV. It might say watching Netflix, right? Okay, next week you guys are going to do a project where you are going to have to get a survey, take a survey of your classmates. That might be a question you could ask. How many hours did you spend watching Netflix last night? Okay, or over the weekend, or how many hours did you spend playing video games? Okay, yeah, some of you would be on the upper extreme and some of you on the lower extreme, okay? So, we're going to do a project next week that's going to involve, yeah, you're going to have to make a graph, you're going to have to collect some data. Not on a poster, you're going to make a Google slide of it. Okay? All right. So line plot just shows where the values are at. Okay, then a scatter plot. We haven't talked about scatter plots yet, but we will on Monday. Okay, a scatter plot is really just scattered dots on a graph. They're placed strategically, though, based on the data. Okay, and it shows the relationship between two data sets. Okay, if we're comparing two different sets of data. And so maybe I'm comparing the height and the weight of students in 7th grade. Okay, I could compare your shoe size to your height. Right? And we might see that the taller you are, the bigger feet you might have. Would that make sense? Yeah. Okay, but maybe not. Some people who are tall don't have really big feet. Okay, so that's why you will see like this really tall person weighs less than this person that's not quite as tall. Okay, because we're all a little different right that way. Some people can be like super, super tall and really, really skinny, and some people are tall and like muscular and built. Okay, right? Yeah. Okay. So a scatter plot, we have two sets of data that we're comparing. So anytime we're talking about two different sets of data that we're trying to put on a graph, we'd use a scatter plot. Okay, so the last slide here. Choose the appropriate data display. So if I said the number of students in marching band each year, what kind of graph might we use to show the number of students in marching band each year? What kind of graph would you use for that? So look back at your choices. What do you think? Okay, so the key word here is each year. We're talking about years. So then which one would you use? Go ahead, Caleb.
Line graph.
A line graph. Why would it be a line graph, Caleb?
Because it shows data over time.
It shows change over time. So line graph would be the one we'd want to use because we're talking about the change over time. We're looking at how many members were in the marching band each year. So in 2019, 2020, 2021. Okay, so we keep track of that in a line graph would be the best choice. All right. The next one, comparison of people's shoe sizes and their heights. I'm comparing shoe size to height. I've got two different things that I'm comparing. What kind of graph should I use? A scatter plot. Okay, because we're comparing two different things, we're going to use a scatter plot. Okay. The population of the United States divided into age groups. What do you think we should use there? If we're dividing it into age groups, like 10 to 19, and age 20 to 29, and age 30 to 39, and age 40 to 49. Izzy, what do you think?
Histogram?
That would be a histogram. Because we're dividing it into age groups, we're going to use a histogram. Okay, when you have those groups of people. Okay? The percent of students in your school who speak Spanish, French, or English. There's a key word in there that should help us figure out. Magna? Circle graph. Yeah, it says percent, right? As soon as we see percent, that tells us we want to use a circle graph or a pie graph. Sometimes it's called a pie graph, same thing. Okay? And homework problems assigned each day. So like the number of homework or problems I assign each day. What would you use there? Tyler?
One more day?
You could, right? We could use kind of a line plot type thing, but I think there's something better that we could use. Izzy?
Line graph?
A line graph. I would use a line graph because it talks about the days, right? How many problems you assign on Monday, Tuesday, Wednesday, Thursday. So a line graph because of the days of the week. Okay, does that kind of make sense? Okay, so we're going to play a little game kit. So I'm going to have you go to